Good afternoon, students. Today let me learn about the topic Le Chatelier's principle. The effect of change in reaction conditions such as temperature, pressure and concentration. This reaction condition on a system at equilibrium can be predicted by Le Chatelier's principle. In a chemical reaction, three conditions will be changed. That conditions are temperature, pressure and concentration. State Le Chatelier's principle. If a system at equilibrium is disturbed, then the system shifts itself in a direction that nullifies the effect of that disturbance. If a system at equilibrium is disturbed, then the system shifts itself in a direction that nullifies the effect of that disturbance. Okay, so in a equilibrium condition, that means forward reaction and the backward reaction, reactant and product concentration same, temperature same, pressure same. At the three condition same, that reaction is in equilibrium condition. That equilibrium disturbed, maybe concentration increased or temperature increased or pressure increased, the equilibrium will disturb. At that time, that equilibrium system shift itself in a direction that nullify the effect of that disturbance. That is Le Chatelier's principle. State Le Chatelier's principle. If a system at equilibrium is disturbed, then the system shift itself in a direction that nullify the effect of that disturbance. First, let me learn about the first condition, effect of concentration. At equilibrium, the concentration of the reactant and the product does not change. In an equilibrium condition, the concentration of the reactant and the concentration of the product does not change. The addition of more reactant and or product to the reacting system at equilibrium causes an increase in the respective concentration. When we add more reactant in the reactant side, the concentration increased in reactant side. So the equilibrium will be disturbed. According to Le Chatelier's principle, the effect of increase in concentration of a substance is to shift the equilibrium in a direction that consume the added substance. Example, hydrogen reacted with iodine to form hydrogen iodide. Hydrogen H2 plus iodine I2. Hydrogen and iodine are reactant. Reactant reacted to form the product hydrogen iodide HI. The addition of hydrogen and iodine. Now this reaction is equilibrium reaction. Now the addition of hydrogen and iodine, the equilibrium mixture disturbs the equilibrium. In order to minimize the stress, the system shift in a product side. The system shift in a product side. Okay. If hydrogen iodide added to the reaction mixture, hydrogen iodide is added to the reaction mixture, the concentration increased in product side. Concentration increased in product side. The system proceeds in the reverse direction. Why the system proceeds in the reverse direction? Because to nullify the effect of increase in concentration of hydrogen iodide. So the next second condition, effect of pressure. effect of pressure. When the pressure on the system increased, the volume decreased. Pressure increased, the volume decreased. Proportionality and the system responds by shifting the equilibrium in a direction that fewer moles of gaseous molecule. There less variable is there. Let us consider an equation. Nitrogen reacted with hydrogen to form ammonia. This reaction is a synthesis of ammonia. Synthesis of ammonia from nitrogen and hydrogen. Nitrogen and hydrogen are reactant, ammonia are product. Let the system be allowed to attain equilibrium in a cylinder with a piston. See here, 2 cylinder is there. 2 cylinder fixed with piston. Okay, let the system be allowed. This is a system. System be allowed to attain equilibrium in a cylinder with a piston. Both cylinders are in equilibrium condition. If we press the piston down to increase the pressure. Now down to increase the pressure, the volume decrease. The volume decrease. The system responds to this effect by reducing the number of gas molecules. So, the formation of ammonia, it produces the formation of ammonia. If we pull the piston upwards to reduce the pressure, if we pull the piston in upward to reduce the pressure, the volume increase. The volume increase. It possible to produce hydrogen and nitrogen. That means it proceed backward, reverse direction. The total number of moles of the gaseous reactant and the gaseous product are equal. The change in pressure gas no effect on system at equilibrium. Okay. So let us consider another one equation. Hydrogen and iodine reacted to form hydrogen iodide. Here 2 moles of hydrogen, here 1 moles of hydrogen, here 1 moles of iodine to form 2 moles of hydrogen. So reactant total moles 1 plus 1 2. Product side 2 moles. 2 moles of reactant and 2 moles of product. Here the number of moles of reactant and products are equal. So the pressure gas no effect. The pressure gas no effect. So delta Ng value is 0. See this equation, the moles, number of moles of reactant and product is different. Nitrogen, number of moles 1. 1 plus hydrogen number of moles 3 equal to product ammonia 2. That means 4 equal to 2. Reactant 4 number of moles in reactant, 2 number of moles in product. So pressure will change. In this equation, hydrogen plus iodine gives hydrogen iodide. Here 2 moles are reactant, 2 moles are product. So here the pressure gas no effect on such equilibrium.